Minasan, konnichiwa, Zamurai Engineer desu. So in this video, let us move on to the next module, number 7 of major topic number 2. So we'll talk about structural loads, and in this particular video, we will explain about dead load. So take note, you already know about these things in theory of structures. Okay, so we will do it a little bit faster. So please review your theory of structure. So let's start with the objective of the course. PhD provides fundamental concepts, principles, and theories under structural analysis and design of steel elements in a structure. So we have the list of topics. We are on the part 2, and now we are on the subtopic number 7 or module number 7 about loads. So what are the structural loads? It is perhaps the most important and most difficult task faced by a structural engineer. Okay, so how to specify and estimate structural load? Okay, that the structure may experience in the future. So the engineer is not only estimating, but is what thinking about the future. Okay, so for example, the building is designed for 30 years. The building is designed for 50 years. The designer should think about the whole 50 years of the lifespan of the building or structure. Okay, not only today. Okay, so the estimate is not only today, okay, but very well in the future, into the future. So prediction, not only estimation, but also prediction. So estimation and prediction could be scientific. So we will not use wayward prediction. We will not use wild guess. We will use scientific guess based on what documents, based on scientific research and studies. Okay, no loads that may reasonably be expected to occur may be overlooked. Okay, may be overlooked not only tomorrow, but 30 years from now, 50 years from now. Okay, so for example, you are designing a residential unit of a newly married couple. So after 50 years, how many of them are living on that house? So today or tomorrow or in the recent future, there are only 2 of them who will occupy the building, the residential house. But even in 3 years, in 4 years, 5 years, maybe there are offspring, okay, babies, okay, so additional occupants. Not to mention the possibility of what? Twins and triplets, okay, and what? From time to time, there are several visitors or guests. For example, there are parties. So take note of those things. Okay. So when we are going to estimate loads, okay, take note, including the time. So in the design, the lifespan of the building is included. In the absence of code, this is the design load. We have a code, but there are several purpose of the code. For example, our code that we are using, the NBCP, NSCP, are the codes that are about the structural aspect, okay, the building aspect of our structure. Okay. Now we are talking about specifically load. Okay, and there is another organization. There is another purpose for this. The purpose for this is to scientifically provide information, data, historical data, put together, okay, about the different types of load. And they actually what call this as ASCE 7. That is the name of this code. ASCE 7 is a publication in the form of a code that could be used by different authorities. Most of them use this as a guide, use this as a standard, and there are some even use this as a code, okay? Adapting it, promulgating it as their local code. This document or publication is entitled Minimum Design Loads for Buildings and Other Structures. So ASCE 7. What is ASCE? ASCE is American Society of Civil Engineers. In our country, we call it PICE. So in the United States, they call it ASCE. And ASCE 7 is the name of the publication or document, as you can see on the picture. Okay, you can see on the picture. This is the latest update. You can see ASCE 7-22. Okay, as you can see here, the number is 7, meaning ASCE 7. That's 22, meaning year 2022. So this year, this is the most updated copy. Provisions for the minimum design loads and associated criteria for buildings and other structures. Okay? So, using this as a guide, we can therefore make a professional estimate of the future load. Okay, future load. Loads are classified to 3 major classifications. One, dead load, 2, live loads, and number 3, environmental loads. Okay, so remember these things. Dead loads are loads of constant magnitude that remain in one position. So we are now starting with the explanation about dead loads. Currently, we will discuss dead loads. Dead loads consist of structural frames, own weight, and other loads that are permanently attached to the frame. Anything that are permanently attached to the frame, they are called dead load, including its own weight. Okay, including its own weight. If you are using concrete beam, the weight of the concrete beam. If you are using steel beam, the weight of the steel beam. That is what we mean by own weight. Okay. So steel frame building dead loads. What are those? Number 1, the frame itself, the walls. Number 3, floors. Number 4, roofs. Number 5, plumbing. And number 6, fixtures. Fixture could include mechanical part and electrical part. So those are the fixture, or sanitary part, or electronics part. So the major ones are here, walls, floors, roof, and plumbing. Okay. For example, fire protection is a fixture. We will include those things as a fixture because why fixture? Because this 1 to 5 are actually the the type of load that are great value in terms of weight and kilonewton or newton, okay, in terms of newton. But those pictures are not so great, but still they may affect. That's why we still have to consider those. Okay. So to design a structure, it is necessary for the weights or dead loads of the various parts of, to be estimated. Okay. Necessary. It is necessary for an engineer to estimate. Okay. So therefore, our training as an engineer would come in handy because the problem solving we can what? Memorize because of every continuous problem solving. We are now going to, without knowing it, memorize the values, the usual values, okay, the common values that will arise. Okay, so because of that, we have the what? Engineering judgment on our being. Not only engineering judgment, we have a technical insight, scientific insight. Okay, so the exact sizes and weights of the parts are not known, okay, until the structural analysis is made and the members of the structure selected. So you estimated, right? Meaning you assume a size, but later on you solve the real size, the required size. Okay, required size. And what happened if the solved size is substantially different from the assumed or estimated size? You have to resolve the problem. You have to reanalyze the problem. So this is what? Iterative process. This is iterative process. So if it doesn't work, so you have to do it again using the more realistic and more practical size, given the previous what? Given the previous result of the computation. Okay, that is what we want to happen, so that our what? Our computation is not actually go to waste. Okay? Okay, sorry about that. I just connected my device into power supply. So, reasonable estimates of structure weights may be obtained by referring to similar types of structures or to various formulas and tables. Okay, so previous experiences from previous design could come in handy. This is the importance of previous experience. Although the design is non-transferable, we can utilize previously solved, previously used assumption, previously used estimate in order to have what? Given data, the preliminary data, preliminary given data, so that we can start computation. We can start the analysis and design. So without any given values, we cannot start analysis and design. We need numerical value. Okay, we need numerical value in order to compute something. Okay, so those are given on the what? Codes, the tabulated value, given on experts' opinion and your own experiences. Okay, so detailed information on dead load is provided actually in table C3-1 and C3-2 of ASCE 7. That's 10, meaning 2010. So this is an old version which I have for free. So I do not have money to buy the 2022. So I don't know how much is the difference between the updates, okay, of the new ones from the old code. So I would like to inform you about that, but we cannot do anything about it but use this old document. Okay, so because that is my copy. So if you have a newer copy, if you have an updated copy of ASCE 7, please tell me about it and or share to me that copy so that our learnings, our study would become what more updated. So updated to the current times. Okay. So let's take a look at the specific values. So you can memorize one or two values out of this. One or two values out of this. Okay? Or even three values out of this. Okay? It will not be a waste of your memory space. Okay? For example, reinforced concrete is a dead load because even if we are going to design a steel framing building, there are times that, for example, the walls, the flooring may be made up of reinforced concrete. What is the weight of reinforced concrete according to the code? What code? ASCE 7. So in SI unit, that is 23.6. This is 23.6. The actual values from the code are this one. 150, 490, 145, 4, 5, 2, 6, 4, 7, 8, and 39. These are the actual values from the code that I have. However, I use a formula and convert those values into SI unit because these are the values we are going to use. Kilonewton or Newton per cubic meter or Newton per square meter. So these are SI unit. Okay? So I converted. So 150 is actually equal to 23.6. Okay? So you can check this. You can check all of this value. Please screenshot this one because we will use these values specifically in our computation. Okay? Okay, so this is screenshot and actually check the conversion. Check my conversion if I have missed something, if I have an error. Okay. So for example, structural steel, 77.1 kilonewton per cubic meter. Take note. What will happen? Almost times 3. Reinforced concrete versus structural steel, almost times 3. Okay. The weight. Okay. How about plain concrete? So plain concrete is 22.8, less than the weight of reinforced concrete. So therefore, the reinforcement, which is inside the concrete, increases its weight actually. Okay. So how about movable steel partition? Steel partition. Okay. So inside the house, inside the room, okay? So 192 Newton per square meter. Plastering. What do you mean by plaster? So the finishing. The finishing using the concrete mixture or what paste, cement paste or mortar. Okay, so using those things, we have what 192 newtons per square meter. Okay. No. Plaster is 240. 240. 192 is movable steel partition. Okay. So what about suspended ceilings? Ceiling. Okay. Ceiling. 96 Newton per square meter. Okay, suspended ceiling. Okay, not concrete, not reinforced concrete. Okay, not movable partition, but suspended ceiling. What about pipe ply, felt and gravel? Okay, that is 288. Okay, Newton per square meter. So hardwood flooring. So hardwood flooring and movable steel partition are the same. They are both 192 Newton per square meter. Okay. What about 2 by 12 by 16 in double wood floors? Okay. If the floor is double wood, okay, so wooden floors. For example, you have what? Basketball court in the rooftop. Okay. What is the load of the roof flooring? What is the load of the roof flooring? If there's a basketball court, which is made up of wood flooring, okay, 336 Newton per square meter, okay. And you can use these numerical values in order to analyze, as in we are using the values in what? Durable structure, okay. Wood stud with the 1/2 inch gypsum on its side, okay. Gypsum board, 1/2 inch, okay. So that is 384 Newton per square meter. Take note. It is the heaviest so far, okay. But clay brick whites, brick whites, 4 inches in thickness, okay. It is 1,871 Newton per square meter, okay. Take note. You can even memorize 1, 2, or 3 of those values. Okay. Okay. We are now on the challenge question for this video. Question number 44. What is the maximum thickness of glass railing? Letter A, 5 mm, B, 6 mm, C, 10 mm, D, 12 mm. Again, what is the maximum thickness of glass railing? A, 5 mm, B, 6 mm, C, 10 mm, D, 12 mm. Again, this is Dr. EYPEI, Teaching Engineering for Nation Building. Minasan, konnichiwa, Zamurai Engineer desu. So in this video, we are going to part 2, major topic, module number 7, but subtopic of the subtopic number 2. Okay, where structural code, but specifically this video is about live loads. Start with the objective of this course. This course provides fundamental concepts, principles, and theories under structural analysis and design of steel elements in a structure. So we have the list of our main topics. We are on the topic number 2, subtopic steel number 7, module 7. But now we're going with the live loads. These are the different types of loads, and we already tackled the dead loads in the previous video. So let us go into the live loads. So live loads are those loads that may be changed in position and magnitude when a structure is occupied, used, and maintained. Okay, so if a load can change its position, so it is called live load. So live loads could be a moving load. Those are live loads that move under their own power. That is what we call moving load. Example are trucks, people, and cranes. Okay, so we are not using trucks in our building, but some high-rise building have parking area inside the building. In the upper floors, there are parking areas in the upper floors. So we can estimate that as our live load. Okay. So what do you mean by movable load? Indifference if compared to moving loads. Movable loads are those loads that may be moved, such as furniture and warehouse material. So they cannot move on their own power. They do not, in fact, have a power, but occupants will what? Design the interior, and therefore those furniture, fixtures, and where materials would what? Be relocated. Okay. So number one, we classify floor live loads. So floor live loads, number one, the minimum gravity live loads to be used for building floors are clearly specified by applicable building codes. Unfortunately, the values given in these various codes vary from city to city. Vary from city to city. Again, for the third time, I will repeat. Okay? The values of the codes vary from city to city. Okay? Take note of that for live loads. Okay? And the designer must be sure that his or her design must meet the requirements of the locality in question. That's why, even though you are already a licensed engineer and have several years of experience in Middle East, for example, if you come back to the Philippines, you will have a different set of assumptions, set of data, okay? Because values vary from city to city, okay? So you have to check, we have to check. Unless otherwise specified, each of these concentrated loads is spread over an area of 6.25 square feet. What do you mean by 6.25 square feet? That is about what? 2.5 feet by 2.5 feet. Okay. So please, your assignment to convert this into SI unit, square meter. Okay. 6.25 square feet. What is this in square meters? Okay. Very specific, very specific. Okay. So typical minimum uniform live load for building. Okay. In difference, there is a typical minimum uniform load for bridge. So this is for building. Take note. Type of building. For example, we have apartment. So apartments, public rooms. They are not the same. 40 pounds per square foot. Okay, 40 pounds per square foot. Public rooms, 100 pounds per square foot. Also, I have a conversion, but I will give you the opportunity to convert this yourself. To convert this into SI unit. What is the SI unit? Newton per square meter. Okay. So 40 for apartment, public room, 100 dining rooms and restaurant, 100. So these are the amount of uniform load, meaning it considers the what? Movement of human being, movement of furniture, movement of tables and chairs. Okay, are already considered. Okay. So office buildings, lobbies, 100. Okay, offices, inside the offices, so 50. So lobby has a greater amount of live load. So there are more live load passing through, okay, moving in a lobby compared to the offices. And that is logical, okay? That is logical, okay? Schools, how about schools? Classroom, that is 40. Take note, classroom 40. That is just equivalent to the apartment house or the residential house, 40. Okay, corridors First floor, 100. Corridors above first floor. So meaning second floor and the rest of it, 80. Okay. So storage warehouses, light warehouses, 135. Heavy warehouses, meaning heavy. So it is a warehouse for what? For unsold cars. It's a warehouse for unsold heavy equipment. So therefore, the load is what? 250 pounds per square foot. Okay. Stores, retail store, first floor, 100. Other floors, 75. Okay. Take note of these things. You can be familiar with these things by continuously using these values. Okay. Those are uniform loads. What about concentrated load? We already know how it works. What are the types of loads in our theorem structure? Uniform load, concentrated loads, increasing load, and so on. Other types of load. Okay. So, concentrated loads. Hospitals operating private rooms and wards, 1,000 pounds. Okay. Manufacturing building, light, 2,000 pounds. Manufacturing building, heavy, 3,000 pounds. Okay. So 3,000 pounds is more than 1 ton. Okay. This is more than 1 ton. Office floors, 2,000 pounds. Retail stores, first floor, 1,000. Retail stores, upper floors, 1,000. School classrooms, 1,000. So school corridors, 1,000. Okay, so the common value is 1,000. Okay. And number 2, so we have number 1, floor load. What about number 2, traffic load for bridges? So I will discuss this because we can use this on the other course, but not here. And also take note, in the upper floors with parking, so there are so many cars, and they will also maybe considering those floors as some sort of a bridge. Okay, bridges are subjected to series of concentrated loads of varying magnitude caused by groups of truck or train wheels. Okay, those are for traffic loads, vehicles. Okay, number 3, impact loads are caused by the vibration of moving or movable loads. Okay, so we have moving loads, we have movable loads, and they could be dropped from a certain height. So dropping those from a certain height clearly would create greater amount of load compared to its own weight alone. Okay, so cranes, for example, picking up loads, and elevators starting and stopping are other examples of impact loads. So elevator moving and then suddenly stop, that is impact load. Moving, then suddenly stop. Okay, that is impact load. Same is true with cranes. Okay, impact loads are equal to the difference between the magnitude of the loads actually caused and the magnitude of the loads had they been dead loads. Okay,